Section 3.4 is called linear and angular speed. And we're going to look at the difference between linear speed and angular speed. So when we have a point P, and then this point P is moves at a constant speed along a circle of radius R, and center is O. Center is O. So this is the circle we have, its center is O, and this is our point P. So the point P starts its travel from here, and it's moving counterclockwise direction here. The measure of how fast the position of P is changing is the linear speed. So position P moves from here to here, then here to here, and then how fast the position is changing, that's the linear speed. If V represents the linear speed, then we can calculate the speed by dividing the distance by time. So the linear speed V can be calculated using the distance divided by time. And this is the speed that we use in our daily life. Every time we want to measure our speed, we just look at how many miles we finished in the determined time frame, and we divide these two numbers to find our speed. So here, S is the length of the arc in this case, because we're moving on a circular path, and time is t. So linear speed v will be calculated dividing the arc length by t. When we look at the angular speed, the same point P, when it is moving from any position to a different position on the unit circle, its angle theta is changing as well. So angular speed is how fast the angle is changing. Angular speed will be represented by W, and then to find the angular speed, we are going to divide the theta, the final angle, by the time that it takes. So W is the angular speed, theta is the measure of the angle in radians at time t. So linear speed is V, angular speed is W. And this is the comparison chart. If you want to calculate your angular speed, you're just going to divide your theta in radians by your time. If you want to calculate your linear speed, you're going to divide your arc length by time. And we learned on the previous section that arc length will be calculated by r times theta. So if you replace the s by r times theta and then divide this by time theta, you notice that theta over t is the same thing as your angular speed. So this is the relationship. You can also calculate your linear speed by multiplying your radius by your angular speed. Here's the first example we're going to study, and this is the homework problem you're going to also practice. We have the point P on a circle, and the circle's radius is 10. Its angular speed is given as pi over 18. So first question is, we're going to find the angle generated by P in 6 seconds using the angular speed. We're going to find first the theta. So since the angular speed is W is given as pi over 18 in the question, we know the relationship that angular speed is always equal to theta, the angle divided by time. Here, we can plug in the numbers we know. W is given as pi over 18. We want to solve for theta, and the time is 6 seconds. You can do cross multiplication, or you can simply just solve for theta. Theta will be calculated using 6 pi divided by 18, which is just pi over 3 radians. So you got the first part done. Theta must be pi over 3 radians. Part B of this question is, find the distance traveled by P along the circle in 6 seconds. So now we have this linear movement. So we want to find the arc length, S, and S is equal to R times theta. We have the R, we have the theta in radians. So R is given in the problem as 10. Theta, we found it in part A as to be pi over 3. So the arc length or the distance will be 10 pi over 3 centimeters. The third part of the question is, can you find the linear speed of P in centimeters per second? So linear speed is V, and it will be calculated S divided by T. Since we calculated the S on the previous section as 10 pi over 3, and we're going to divide it by 6 seconds because it was given in the problem. Copy the first fraction, multiply it by the reciprocal of 6, which is 1 over 6. We're going to end up with 5 pi over 6 for the linear speed for this question. And this is the problem type we're gonna practice on the homework.